Hello there, partner. I am doing part D of the properties of acids in base lab. This one I'm doing for you because it has counting involved. I'm going to be counting, so it's a little bit of a qualitative as opposed to the very quantitative parts A, B, and C. So I had to do this one for you. And what I have is I made two adjustments. If you look at your procedure, it calls for 1 molar HCl. I have double the concentration, 2 molar, made by Moi. And this one is 1 molar NaOH as opposed to 0.5 called for. I did not make this one. This one is actually, I've used a titration on this one with a standardized solution. It's not quite 1 molar. It's a little bit, not that I'm throwing my colleague under the bus, but I am, I guess, in that it's a little bit off, and hopefully that will make a difference, though. It should not be enough, hopefully, to make a difference in the lab. But this is 1 molar and 2 molar, and so I've doubled the concentrations called by the procedure from 0.5 to 1 to 1 to 2. All right, so we've doubled the concentration. So they should make that change in the procedure, and it should make sense to you when we get a result, hopefully. Okay, so what I have is a test tube here. I've got a dropper pipette here. I took 2 dropper pipettes of equal volumes. This is the acid, and that's the base. When I add the acid to the test tube, I'm going to add 10 drops. And adding drops is not the easiest thing in the world because you got to get them right down there and you got to count right, and that doesn't sound. Okay, here we go. Can you see that? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Ooh, that last one was not a big drop. It's hard to get drops of equal droppage. I mean that up. I'm going to take the phenolphthalein. That's an indicator. Hopefully at this point you know something about phenolphthalein, and we'll put in 1 drop. We don't want to overdo it with this. I do want to make sure that it contacts the bottom of the test tube. 1, it did. Sweet. Well, pardon, that was well done, well played. All right, let's cover this up. Now I got to add the base, the sodium hydroxide, to it. Now it does call for me to take a pH reading at this point. I'm not going to do that. And the reason I'm not going to do that is because since there's so few drops in here, and these drops are very small drops from the test, the pipette that I used, that by doing that I'm going to absorb some of the NaOH, and I don't want to do that. I mean, I had this ready to go and decided against it, so I'm not going to do that. I'll do it at the end, but I'm actually not going to test the pH now. We're just going to have to trust that it's just HCl, okay? We know that's a strong acid. It is going to be acidic. My guess is going to be right down. I've done this before, so you'll have to trust me on this bad Larry here. It's right down around 2. Here it is, right 2 on the pH scale. Just trust me on that. You're just going to have to. I don't want to scutch with my results. So we have a pH reading. It's HCl. It's going to be about 2. You'll have to trust me on that. I suppose I can go back and do another test tube video with you and show that to you. But for now, keep going. All right, so let's go on and get our NaOH. We're going to add drops until we turn our indicator. Indicator right now is clear, right? It didn't turn the color of anything. Where are you? There you are. Clear. Okay, add some drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That one kind of piddled out. There was like 11 and a smidgen. You see, not exact science here. We're not doing 11 and a smidgen. We're not using what are called burettes, which should be much more accurate, but we will. We will very soon. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's turn it purple. But it didn't stay purple, and it's key to have it stay purple. It's 20 drops. 21. 22. Still not staying. No, that's an air bubble drop. No, we don't want you. Get out of there. 23. Still not staying. 24. I bet it's going to be one more 25. Yeah, oh, you're not even seeing this. I thought I was showing it to you. We've got some pink just barely staying there. There is some pink in the bottom of that test tube. I don't know if you can see that. So that's 25. I'm going to call it at 25, but we'll add one more just to show. Oh, that wasn't a good one. There we go. There we go. That was 26. The complete, I mean, it just flooded it with color at 26. And I knew that because at 25, we had just a small tinge of pink at the bottom of the test tube. So we're calling it a 25. So the amount of drops that we added for the HCl was 10. The amount of drops that I added for the NaOH was 25. All right, so well, we can get a pH reading on this one now and see what we come out with. And we'll just turn this to the side, saturate, get it nice and blue, huh? And if you look at that comparison here, here's your color coordination thingy here, and here we got, where are we, right in here? Yeah, I would call that, I mean, it's really tough to tell between 12 and 13. I'd go 12, I'd go pH at 12 on that. What we can do is we can go back and I'll grab a test tube here. I'll just dump some acid in here. And we'll dump 1 drop of the phenolphthalein. Okay. Just to show you what really, come on. You are just jammed back in there, aren't you? Just to show you what well, this is not a happy day. Come on. Cooperate, please. What the pH meter reading would be on this. So this would be, this must be exciting for you. Oh, it's the wrong one. Like I said before, you don't want me as a lab partner. Terrible. Absolutely terrible. I am terrible. I'm like that movie that came out that I thought lived up to its name. Super bad. Get it? Super bad. It was super bad. Okay, it's funny. Okay, here's the acid. We can see how pink that is. And here's the indicator. Indicators, I always, when I was in chemistry, we used to say red acid, blue base. Easy to remember. Very easy to remember. All right, so if we check out the pH on this one, we've got a pH right down there around 1. Maybe even you might argue it's 0. I don't know if you can see that. Yeah, about 1. So that is extremely acidic stuff because it's a strong acid. All right, and we have a strong base, and that makes that blue very bright blue. So you can see that. We got some sweet color there, okay, on the indicators. All right, now here's the thing. With this part of the lab, we're not doing what's called a titration. If we were doing titration, which we will be in 2 labs from now, and we'll be using very accurate measurements and very accurate dispensing techniques to make sure that everything is equal. I'm dropping from little plastic pipettes, trying to get equal drops, but they're just not all equal. They're not. Sometimes the air gets caught and it kind of messes up. The other thing too is my NaOH was, I know it's not 1 molar. It's more like 0.91 if I remember doing the titration with this. So it's a little weaker than 1, which if you think about it makes some sense. I mean, this is twice as concentrated as this, and so a strong acid and a strong base should neutralize each other. And what we did is we ended up with a pH was well above, because once I added that extra drop of NaOH, it only takes 1 extra drop to shoot the pH, skyrocket it, and get that nice blue color. So it's not neutral because I didn't have equal amounts. But at 25 drops, It's a little bit more drops than I would expect. You usually typically expect, well, it's a 2-to-1 ratio in concentration. You expect a 2-to-1 ratio in drops. It would take twice as much of the weaker to neutralize the stronger. So I would be expecting somewhere around 20 to 22 or maybe 23 drops. Again, it depends on the size of the drops. And I also know this is a little bit weaker than 1 molar. So it could maybe another drop or 2 because of the weaker concentration. But that's more like, yeah, 2 drops actually. 25 off my 10%. So yeah, that's actually about 3 drops. The concentration of this being really around 0.91 makes an extra 3 drops needed to neutralize. So, based on that, it makes sense. The data makes sense. It took a little bit more than twice as much of the 1/2 concentration, and that's what the results showed. So we were in the ballpark, but it's not exact because we don't have what are called burettes. All right, so I've done enough babbling. If you stuck with me this long, that's your data, and I've also given you some insight into the results and why they are what they are and what are some likely causes for that. All right, so we'll shut this part off and see you soon at the board.